Welcome back. Last class we started with binary search. Before that, we'll just go through what is searching. Searching is an operation wherein we search or we find whether an element is present in a list or not. Here, we are not concerned how many times it is repeated. We just check whether the element is present in the list or not. If the element is there, we will print the element found, otherwise the element is not found. And you have two searching techniques for your syllabus. One is linear search and the other is binary search. Linear search is a simplest searching technique wherein it is an unsorted list. You go on comparing the search element with each element in the list starting from the first element and till the last element you will go if the element is not found. Otherwise, if the element is found anywhere in between, you will just stop searching and you will note down the location of it and print it to the user as the element found. Right? Suppose there are 1000 elements in your list and the element is not at all there. Your search element is not there in the list. So how many comparisons or how many searches you will do? 1000, right? Because you need to go on comparing it from the first to the last element. Or if it is there somewhere in the end, that many comparisons you will do. So there is best case would be wherein the element is the first element with first search only you get it, comparison only you get it. Or worst is when the element is not there at all or it is somewhere in the end. And the average is you find it somewhere in between. Whereas in binary search, the array has to be sorted in an order. That is, you cannot do binary search on an unsorted list. The list has to be sorted. It can be either in ascending or in descending. It does not matter, but then the array has to be sorted in an order. The binary search algorithm can be used with only sorted list of elements. If the elements are not sorted, you cannot use binary search algorithm. And then what does it do? It will divide, right? That is the procedure. We found the mid value and then compare it with the element in that location. So you go on dividing the array. First, you compare the search element with the middle element. If it is not same or if the match is not found, you will check whether it is greater than that or lesser than that. And depending on that, you will either check in the right side of the list or to the left side of the middle element. You will not again check the entire array. Again, you go on dividing the same array into many sub arrays recursively. Recursively is continuously until the low value becomes greater than the high value. Once the low value becomes greater than high, you stop searching and you will exit the loop. And LOC is a variable wherein you will store the location of the element found. If the element is not found, then it remains -1. Otherwise, whatever 0 to n minus 1, wherever the element is found first, LOC would take that value. Correct? Please go through this again. And it reduces the search because you're not comparing it with each element. You're going to divide it again and again. So the number of comparisons becomes less and it is very faster. Please go through these three statements again. So you went through this. Now we'll start with the algorithm of it. So this is the statement of the algorithm. A is the sorted array of n elements. So what is A? A is a sorted array. Whenever you're writing the statement, please don't forget to mention the word sorted. in reference to binary search. So A is a sorted array of n elements and ELE is the element being searched, right? So ELE is the element being searched in the array, and low and high identifies the positions of the first and the last elements in the range. That is, low is the position is nothing but the index value of the first element in the list, and high is the index value or the position of the last element in the list, and mid identifies the position or the index value of the middle element in the list. So we are clear now what is A, what is N, what is ELE, what is low, what is high, and what is mid. Now we'll start with the algorithm. So step 1. What is step 1? Step 1 is start. We are starting it. Okay. After that, I have step 2. Step 2, I should first start giving initial values for low and high. So what is low? Low is nothing but the index value or the position of the first element in the list. And we know that the index value starts from 0 to n minus 1. So the index value of the first element should be 0. Step 3. High is the index value or the position of the last element. So how many elements are there? N. So the last element would be n minus 1, right? So the last element would be n minus 1, because 0 to n minus 1 would be my subscript values or index values range. So 0 to n minus 1. When low is 0, because it is the index value of the first element. High is the index value or the position of the last element. That is why high is equal to n minus 1. Step 4, LOC is equal to minus 1. To begin with, I'll assume that the element is not found in the list. Once the element is found, LOC will take the value of the position of that element, or I can say the index value of that element. Now, what I have to do? Step 5. Now I will have a loop, because I need to repeatedly divide the array until I get the search element, or I would have searched the entire array. Right? I have to do the repetition. Divide, compare, divide and compare until I find the element or I have compared with all the elements. So it has to be in a loop. While low is less than or equal to high. Once low becomes greater than high, you are going to stop this, right? Do. What am I going to do? First, I am going to find the mid value, right? MID, mid. Last class also we did the same thing. What is it? Low plus high by 2. Low plus high by 2 would give you the mid value. After that, I have to compare. That is the search element to the element present in the position of the mid. That is what I did. So how do I compare? Using a decision making statement. If, yes, ELE, that is the search element, is equal to A of mid, right? Because I need to compare it with the element present in the mid position. So if ELE is equal to A of mid, then what happens? Then element is found, right? Because if it is true, then LOC should take the mid value. Yeah, because if the element is found, then the element is present in the position mid. So LOC should take the position or the index value of the element, which is nothing but mid. So I'll say LOC is equal to mid. After that, I need not compare again. Like I'm not checking how many times it is repeated. So what I will do, I have to go out of the loop, correct? Because I have found the element. If this is true, I need not. I haven't closed my while here. So end of while I have not encountered anywhere. So LOC is equal to mid. After that, go to step. I will leave it once I write that step. That time I will come and put the number over here. If LOC is ELE is not equal to A of mid, then I should check whether it is greater than A of mid or less than A of mid. Yesterday that is what we did. If it is not equal to A of mid, then I need to check if ELE, that is the search element, is greater than A of mid. Then if ELE is greater than A of mid, correct? Then what I have to do? Where will the element be if ELE? Then it should be after the mid element, the elements, whatever elements are there it should be present, right? If the element is greater. Before the mid element, you will not get if the array is arranged in ascending order, that is starting from the least to the highest. If the array is arranged in ascending order and the search element is greater than the mid element, then the element should be present after the mid element, not before, right? After the element present in the mid position. So which one should I change? I should change low. Step 10. Then I will say low is equal to mid plus 1. I need to write one end of here. After that, go to step. Yeah. After going there, the end of, go to step. Low is equal to mid plus 1 if the element is greater than the element present at the mid position. Getting it? Then I will say step 11. If it is not true, what will I do? See, if the element is not greater than A of mid, it will be else, right? Else, I need to change high value because the element would be present, that is the search element would be present before the element present at the mid position. So I have to change high is equal to mid minus 1, right? Then end if. So this is what I'm going to do, and end of while also. I'm going to end my while also, while loop. Because what am I doing? First, until low is less than or equal to high, first I am going to find the mid value. Then after that I am going to check whether the search element is equal to the element present at the mid location. That is, ELE is equal to A of mid. If it is true, then I am going to make the location is equal to mid and go to step. With step, I will write the step number there and if. Else, if it is not equal, if the search element is not equal to the element present in the mid position, then I need to check whether it is greater than that or lesser than that, because it can be either present to the right element side of the elements or to the left side of the mid element. It cannot be present on either side at the same time because it's a sorted list. So I'll say if ELE is greater than mid, then it has to be present after the mid element, that is the element present in the mid location if the array is arranged in ascending order. That is ELE greater than A of mid, then I make low is equal to mid plus 1. Else high is equal to mid minus 1, because the element should be present before the element present in the mid position. End of if, end of while. After that I need to check and print whether the element is present or not. How do I do that? Using the LOC value, right? If LOC is greater than minus 1. If it is greater than minus 1, print, what am I going to print? Element found in the location LOC. So what should I write here? I should write go to step 12, because I have given LOC is as the mid value, and go to step 12. In step 12, if LOC is greater than minus 1, element found in the location, and I am printing the LOC value here. Otherwise, if LOC remains as it is, so step 13, else what will I do? It will print element not found, because if LOC is not greater than minus 1, it will be equal to minus 1 only. Print element not found. Then step 14, exit. This is my algorithm. We'll go from top. See, what am I doing here? To start with, I will say low is equal to 0, high is equal to n minus 1, because low is the index value or the position of the first element, and n high is the position of the last element, and my elements are 0 to n minus 1. and I will say LOC, that is the location of the element, is -1 because to us I assume that the element is not present. That is why I will say -1. After that, you need to go on checking until the high value is greater than or equal to the low value. That is, low is less than or equal to high. Once low becomes greater than high, you stop searching. Okay? Mid is equal to low plus high by 2. So you have to find the mid value, that is the index or value or the position of the middle element. So if the search element is equal to A of mid, that is, if the search element is equal to the element present in the mid position, then low is equal to mid plus 1. I'll say low is equal to mid plus 1 because it since the array is sorted, it can be either before or after the mid element. That is why if it is greater, then it has to be after the mid element when the array is sorted in ascending order. So low is equal to mid plus 1, else high is equal to mid minus 1. End of for, end of while. This will go on executing until the low value is less than or equal to high. Once low becomes greater than high, it stops executing. And then you compare it whether the LOC is greater than -1. Yes, then element found, otherwise element not found, and you stop it. Hope you have noted this down. Please go through that again. Now we'll start with the program. It's a practical program, so please make a note of this. What is the statement of the program here? Write a program to search for a given element in an array using binary search method. So you have to use binary search method to find an element, that is whether the element is present in an array or not. And if the element is present, you are going to print the location of it, the first occurrence, right? Location of it. And if the element is not present, you are going to say the element not there. So this is the thing what you need to do. So we'll start with the program. Let us maximize this so that it will be easy for you to read it also. So how does my program start? Hash include iostream.h. Yes, hash include iostream.h. Hash include conio.h. Then class is a keyword which states that it's a class. I'm going to write a class program because in lab you need to write class programs. Class binary search is not a keyword, so I can name my class as binary search. Private, what do you mean by private? It's an access specifier, right? In that I will have int a, which is an array of maximum 40 elements. The name of the array is a. Then I will say LOC N ELE, then low, high, and mid. These are all integer variables. What are the variables I am going to have? I'm going to have an array of maximum 40 elements, and I have LOC, one more variable, and N is the number of elements because I need not enter all the 40. So N is the number of elements, ELE is the search element, low is the position or the index value of the first element, high is the position or the index value of the last element, and mid we are going to find it, but it is the index value of the middle element in the array. So these are the variables which I am going to have. After that, what am I going to do? I should have my member functions, and I would be writing it in public so that I can access it from main and call it public. So this I would need a constructor because I need to give initial value -1 to LOC, and I would be doing it using the constructor. Constructors are special functions written in the public section of the class which has the same name as the class name, and they do not return any value. So there is no return type. Binary search is the name of the class, so it is also the name of my constructor. And since I'm not passing any arguments to it, it becomes a default constructor. When does it get invoked or executed? Whenever I create an object for the class, it gets executed. And to take in the array, void input. Okay, void search is for searching the element, and then to display the element I'll say void display, then I'll end my class here. So what are the member functions in my class? I have three member functions: void input, void search, and void display, which do not return any value, and I am not passing any values to it. Binary search without return type because it's a constructor. It has the same name as the class name, and it is declared in the public section of the class. The data members of the class binary search are an integer array of maximum 40 elements, LOC, N, ELE, low, high, and mid. So I closed my class here. Fine. Now I will write the definition of these functions. That is, I am going to define this function outside the class. I have declared it here and be defining it out. How do I define a function? Declaring inside, writing it outside. The general syntax is return type of the function, name of the class to which belongs to, scope resolution operator, and name of the function. This is the general syntax. Since the constructor do not have any return type, I will be writing directly the name of the class to it belongs to. Binary search, right? And then scope resolution operator and name of the function. LOC is equal to -1. This is the end of my constructor. I am giving an initial value -1 to LOC. After that, let me write my input function. Return type of the function Name of the class to which it belongs to. Scope resolution operator. Name of the function. So you cannot terminate the function here. Take out that semicolon because if I write it, it gets terminated here itself. So first, what should I say? Cout, enter the number of elements in the array. Correct? It's number of elements in the array. Then cin n. N is the number of elements in my array. Cin n. After that, what will I do? Cout, enter array elements. After that, I need to take in the element, which is again a recursive operation. So I will be putting it in a loop. For, let me add, since I have a variable, I can either declare it there or I'll say I here. Int I. So I is equal to 0. I less than n. I plus plus. Cin a of I, correct? A of I, and then I'll close my for loop here and I'm closing my function here. So please have a look, make a note, then we can continue with the search function. Binary search input function here. We finish the constructor wherein I gave an initial value to the LOC variable assuming that the element is not found in the list. Then after that in the input function I ask the user to enter the number of elements in the array. I have taken in the n value, so the array index values would range from 0 to n minus 1. After that, I ask the user to enter the array elements I have taken in the array elements, that is, I have read the array. Fine. Now, let me start with my search function. So, how do I write it? Return type of the function, name of the class to which it belongs to, scope resolution operator, and name of the function. So, here, what do I need to do? First, I need to give the initial values of low and high. Apart from that, I need to ask the user to enter the search element because I have only taken in the input function, I have only taken the elements of the array. I haven't taken the search element. So, cout and enter the search element. Cin ELE. So ELE is the search element. After that, I will say low is equal to 0, high is equal to n minus 1. Yes. To begin with, low is equal to 0, high is equal to n minus 1, and I have asked the user to enter the search element, and I have taken in the search element. After this, what do I need to do? I need to write my loop, right? While low is less than or equal to high. I'll write a trace for this only for the search function. Okay, please make a note of this program. While low is less than or equal to high, I'll start my while here. What will I do? After that, I need to find the mid value, right? Mid is equal to low plus high by 2. Hmm? Now I need to compare it. So how do I do that? If ELE is double equal to, this is a program, not an algorithm. So I have to use the relational operator here, not the assignment. Relational operator is double equal to. So what will it do? It will check whether the LHS is equal to RHS or not, right? And if it is equal, it gives the true value, otherwise it will give me a false value. So if ELE is double equal to A of mid, that is the element present at the mid location or mid position, then what I have to do? Then I will be starting my if. I will say LOC is equal to mid. Okay, I'm assigning the value of mid to LOC, and then afterwards, because I don't have to continue further, I can go out of the loop because I already found my element. So I will go break is a jump statement. When uncounted, will go out of the loop to the first line after the loop and it starts executing. So I will have a break here only if the element is equal to mid. Otherwise, what will happen? See here, my if ends here, but then else. Suppose if the element is not equal to A of mid, then I should have my else, right? So what will happen to my else? Else, again in else, I have to see if. Now again I have to check whether the element is greater than A of mid or less than A of mid. So ELE is greater than A of mid. If the element is greater than A of mid, what I should do? Yeah, by this time in the this thing also I have explained it to you. See here, if the element is greater than A of mid, it should be present only after the mid element, right? After the element at the mid position, then only it will be, the element would be present if the array is arranged in ascending order. So I should change the low value. So what will low become? Low is equal to mid plus 1, right? Else, if this is not true, this else is for the inner if. What am I going to make? Else, if this is not true, high is equal to mid minus 1. Okay, if the element is greater than A of mid, I am going to change low to mid plus 1. Otherwise, if the element is not greater than mid, automatically it will go to the else part, and here I am making high is equal to mid minus 1, because it will, if the element is smaller than the search element, the element at the A of mid position is greater than the element, it will be on the right side. So I have written it here properly. If the element is greater than A of mid, low is equal to mid plus 1. If the element is less than A of mid, it automatically goes to the else part. High is equal to mid minus 1. This would be my closure of my outer else also. So then what I have to do? Should I write something more? No, right? Then this is my closing of while. The closure of while. See, this is the if, then else, the outer else gets closed here, the inner else here, inner if here, and the while gets closed here. Then I will close my function also. Then I will close my function also. So let us write a trace for this. Please don't write whatever is there inside this. This is just a trace for your understanding. I am writing a trace. Don't you can write it separately, but this one is the working of this function. So suppose uh, the user after the input function, I have entered these are my elements like 11, 33, 80, 89, 99 and 100. Yes, it is in ascending order, right? So this would be in A of 0 position. Let me give more space among elements. So here it would be A of 1, then I have A of 2, then I have A of 3, then I have A of 4. So these are the locations. What is, for example, let me go up here. This is my array. Search function, how is it starting? Okay, see out, enter the search element. I need to enter the search element. Yes. For example, if the search element, that is ELE, is equal to 100. If I am searching for an element 100, yes, the next line of it is low is equal to 0, high is equal to n minus 1. That is the index value of the last element. So, what is the low value here? Low value is low is equal to 0. That is the index value of the first element, and high is equal to n minus 1. So, which is the index value of the last element, that is 4, right? The last element is 100. The index value of 100 is 4. Okay, that one we established. After that, what do I have? I have a while low is less than or equal to high. So, what is low here? So, 0, 0 less than 4. It is true. Yes. So I will come inside the while loop. 0 less than 4 is true. I am coming inside the while loop. I need to find the mid value. That is, mid is equal to low plus high by 2. So let me find the mid value here. What is low? It is 0 plus high is 4. by 2, which is equal to 2. So mid is 2 here. After finding the mid value, what am I doing here? I have an if ELE is double equal to A of mid. Okay. What is ELE? Comparing, what are the two comparisons I'm doing? ELE is 100 double equal to A of mid, A of 2, which is what is A of 2? A of 2 I can say 89. So what am I comparing? 100 double equal to 89. They are not true, false, correct? So if will not execute. Will if execute? No, because it is false. So it will skip if, it will directly come to else part. So in else, I am checking if ELE is greater than A of mid. So in the else part, I have, what is there? 100 double greater than A of mid, that is 89, correct? True. So when it is true, what will happen here? Low is equal to mid plus 1. So what should I do? Low is equal to what is mid? 2 plus 1, which is equal to 3. Low becomes 3. After that, are there any statements here? No, it won't go to else, because if it is true, only one of that will get executed, and I closed it. So it will go, since I have not exited the while loop, it will go back to the header of the while loop. So what is low here? For the second iteration, see, one iteration is done for the while loop. For the second iteration, what is low? Low is equal to 3. 3 was there, right? And high I have not changed, so it remains 4. Now check for the condition in the header of the while loop. Yes, 3 is less than 4. It will come inside the loop. Mid is equal to low plus high by 2. So let me do this. Mid is equal to low plus high by 2, which is nothing but, what is low? 4, 3 plus 4 by 2, which is 7 by 2 is 3.5. Since I am doing integer division, I will only take in the integral part of it, not the fraction part. So it will be 3. So what is the width value here? Mid value is 3. Now what to have here again? I have, after that, if element is double equal to A of mid, I have to compare what was the element here. Element is 100 double equal to A of 3. What is A of 3 there? It is 99. 99. So not equal. So if loop becomes false, so it goes to the else. In else, again I have an if there, right? Inside else I have written an if element is greater than A of mid. Yes, 100 is greater than 99. So low is equal to mid plus 1. So I'll say 100 greater than 99, true. So it will say low is equal to mid plus 1, which is 3 plus 1, 4. correct? So low is equal to 4. After that there are no statements, so it goes out of the loop. One more iteration of the while loop is done. It goes to what are the new values of low and high? Low is 4 and high is also 4 because I have not changed high. So what does the while loop statement say? It says low is less than or equal to high. So here low is 4 and high is 4. So low is equal to high, still it is true. So it will come inside and I need to find the mid value here. What is the mid value? Mid is low plus high by 2. So mid is equal to low plus high by 2, which is nothing but what is low? 4, 4 plus 4 by 2, which is 4. So what is the mid value? 4, right? Now after that what is there? It goes to the if ELE double equal to A of mid. So what is ELE? 100. What is A of mid? Mid is 400. Correct? So if 100 double equal to 100, true, it will come inside the if here, right? So what am I doing inside if here? LOC is equal to mid and then break, that is going out of the while. So what will be the value of LOC here? LOC is equal to mid. LOC is equal to, what is the value of mid? 4. So LOC is equal to 4 and I had a break. I went out. Hopefully you have understood the trace of this algorithm with this example. Now I'll just erase this because I need to continue with my program. I just wrote the trace of it. When you write a trace of this, then only you will understand the program in a better way. Okay. So else ends here, outer else ends here, and then my function also ends here. Now I need to write my display function. So return type of the function, name of the class to which it belongs to, scope resolution operator, and name of the function. What is the name of the function? Display. So what are the things I'll be writing in my display function? Let me first write cout the entered array is. I'm going to I'm going to print the array also so that the user will know properly, right? I is equal to 0, I less than n, I plus plus. Cout a of I, single backslash t. I got what happened here. Okay. If I okay, I will and I'm going to print my array here. After that, I will print my search element. Cout search element. After that, I need to print whether the element is present in the list or not. How will I do that? If LOC is greater than -1. Cout element found at location close it, else cout element not found. Yeah, this is my if and else, and then let me close my display function. So what am I doing in my display? I'm first printing the array which is entered by the user. I'm also printing the element which is the search element entered by the user, and I'm checking if LOC is greater than -1, the element is found and in the LOC location, else the element not found. This completes all the three functions, right? Now void main. I need to write my main function. Void main will say clr scr clear screen. Then I have to create an object for the class. When object is created, then only the memory would be allocated, and then the default constructor. We had binary search, one default constructor wherein I assigned an initial value -1 to LOC. That gets executed in this line. After that, I need to call my functions. First, I have to call my input function. Then I need to call what? My search function. After that, display function. Get head so that it will be there on the output screen. This ends my main. So this completes my program also. See here, this is my entire program. I have an array, location, element, low, high, mid, and I. So this is the constructor. When I created an object, this would be executed. After that, I have binary search. wherein I ask the user, the input function, I'm asking the user to enter the number of elements and then the array elements. I'm closing it there. After that, void binary search, I'm calling the search function. In that, I'm asking the user to enter the search element. After that, to begin with, I'm giving initial values to low and high, and then I'm writing it in a while loop because the searching continues until the low is less than or equal to high. Once it becomes greater than high, that is the low value becomes greater than the high value, then I need to stop searching because I would have searched the entire array and I wouldn't have found the element. So how do I find mid? That is the index value of the mid element is mid is equal to low plus high by 2. I'm going to do integer division here. After that, I'm saying if the element, that is the search element, is equal to the element at the mid position, then I'm going to just assign LOC is equal to mid and I'm going to break, that is go out of the while. If it is not equal, it goes to the else part. In the else part, I am checking if the element is greater than the mid. Yes, if the element is greater than the element at the mid location, that is A of mid, low is equal to mid plus 1. Else, high is equal to mid minus 1. I am closing my function. After that, what am I doing? I am going to print the array, right? I'm going to print the array. Say whenever you are writing, you need to do it properly. Like the array has to be printed. The search element, what was the search element entered by the user? Print it and then print whether the element is there in the list or not. If it is there, what is the location of it? If it is not there, you just print element not found. And this is your main function. Please make a note of your main. By this time you would have finished writing the other. Please make a note of your main function. Then we'll see the execution of this program. We finished with the binary search algorithm as well as the program. Hopefully you have understood that execution, and we'll also discuss the difference between linear search and binary search in tomorrow's class. I'll show you the execution of this also tomorrow. Please make a note of the homework question for today. Write an algorithm to search an element in an array using binary search. Take care, stay safe, see you tomorrow. Bye bye.